Hello everyone, today let's solve the problem number 543, diameter of a binary tree. So what the question states here, let's come to the example part here. We are given a root of the binary tree. So we are given the root of the binary tree. You can clearly see here, right? So we have the elements 1, 2, 3, 4, 5 within the root, right? We need to find its diameter means here the longest path between any two nodes. The longest path between any two nodes. In the figure they have clearly mentioned here, right? So in the figure they have clearly mentioned here. So either we have to consider this one, we have to consider entire this one starting from the 4, this one 3, this one thing, and starting from 5, this one also. These three we have to consider, right? So this will be, we have to consider 4 2 5. So, and one more thing is 4 2 1 3, right? And also we have to consider 5 2 1 3, right? So and then we have to consider the maximum of it 4 to 5. Here we have 4 to 5, diameter is 1. Between the nodes they have strictly mentioned, right? So this between two nodes, this is diameter 1 and this is diameter 2. So we have 2 for this one, right? So we have 2. So let me delete this one entirely. Now we have the idea, right? So for this one, 4 to 5, this part, so this will be 1 and this will be 2, right? For 4 to 1 it will be 2, diameter is 2. Now we have to consider 4 to 1 3, 4 to 1 3. So this is 1, this is 2 and this is 3. So the diameter for 4 to 1 3 is 3, and for 5 to 1 3, this one also we have to consider. This one is connected, right? So this one also we have to consider. This one will be 1, so 2 remains same, 3 remains same. This is also 3 basically, right? So the maximum of this one is 3. So we will return 3 as the diameter, right? So this, the will return 3 as the diameter. So this is the approach that we'll be going with basically. This is the approach that we will be going with. So just give me a second here. Yeah, so here we are making use of the DFS, right? So we are making use of the DFS, or we will be making use of the DFS. While we write the code, you'll get to know this one clearly. So we have already discussed the approach. So we went with the DFS approach itself. Basically, we went for this one, 4 2 5 and 4 2 1 3, this part, and finally this one 5 2 1 3, this part, three parts, right? So among that one, max we need to consider. So among 2, 3, 3 and 3, 3 is the maximum. So we will return this one. We will return this one basically, right? So we'll return this one. So output will be quite obviously here in this case. It will be 3. I hope this part is completely clear, man. I hope this part is completely clear, right? So let me come out of this one. Yeah. So now we have idea on the approach. So we will be going with the DFS and yeah, we'll be going with the DFS mainly, right? So we'll be going with the DFS mainly, right? So also we know the approach. So we know the question correctly. Now what is the diameter, and we have to go with the this one, largest diameter, right? So largest path basically, right, to find the diameter. So in this case we have to get 3. Either it can be 4 to 1 3 we can consider, or 5 to 1 3 we can consider, right? So what will be the, accordingly with the approach, what will be the time complexity and the space complexity here? The time complexity would be big of n. The time complexity would be big of n. Why it is big of n here? So we are visiting each node exactly once. We are visiting each node exactly once. This will lead to the time complexity big of n. So what will be the space complexity here? The space complexity would be big of h. This will lead to the yeah, this will lead to the big of h space complexity. And here in this case, h is due to the recursion stack. H is due to the recursion stack. H is due to the recursion stack here. So I'm speaking of the recursion stack here. H is due to the recursion stack. And I mean, h is nothing but the height of the tree, and big of h is due to the recursion stack basically, right? So recursion depth is big of n. We know this one. Recursion depth can go up to big of n. So space complexity we can write big of n, but it is we have to consider the worst case, nothing but for the skewed tree, right? So height of the tree in the worst case it can be big of n, right? Best is big of logarithmic n, and worst case it would be big of n. and we will be considering for the skewed tree, so it is better to go with the big of h rather than big of n, right? So the space complexity would be big of h and the time complexity would be big of n for the code that we'll be writing in the future. So as we are completely familiar with the approach and complexities, we are good to write the code. Let's start writing the code. Let's start writing the code. First step here would be we have to store the final answer somewhere, right? So we have to store the final answer somewhere. Let me use this one globally. So let me do one thing. We haven't done this one, right? We haven't used any global this one variable. So I'll just go with the max diameter equals 0. We are storing the final answer within the max diameter variable. So let me come to the main method here. So this one is diameter of binary tree, right? So within this one, so we will be making use of the DFS, right? So we'll be making use of the DFS. First, let's do one thing. Let's perform the DFS, or let's write the let's go with the helper method or the helper function DFS. So I'll just go with here private int DFS of this one tree node node. This is fine. So within this helper method, first base case would be if the height is null, then we have to return 0. Then we have to return 0, right? So if we don't have any node at all, so here in this case, if node equals null, then we have to return 0 in this case. This is the base case. We know this one, right? So then we have to recursively get the left and right subtree, right? So for the left, I can just write it in this way. Left equals, so DFS of this one, node dot left, node dot left. Same, let me copy the same thing and let me paste it over here. This one, I'll just do right here. This one would be node dot right. This is fine. So here, yeah, this is fine. So next, let's update the max diameter at the current node. This will be max diameter. So let me copy this one. So max diameter equals math dot max of again max diameter, and this will be left plus right, left plus right. Right, so we have to update the max diameter at the current node. This is fine. We know this one from the approach. Finally, we have to write, we have to return the height of the current node. We have to return the height of the current node itself, right? So here in this case, I can just go with return math.max of this one left comma right plus 1, because binary tree indexing starts from 0. Binary tree indexing starts from 0. That is the reason we have been given, so I have given plus 1 here. So this is fine. So now let's make use of the DFS within the main function. So here what shall we do? This will be DFS of root. This will be DFS of root, means we have to start the DFS from the root itself, right? We have to start the DFS from root. So I'm just making use of DFS of root here. So the next step is we have to return the maximum diameter found. We have to return the maximum diameter that's found, right? So I can just return here, can just return max diameter, right? So this is it for the code. Let me format the code once and let me hit the run button. I hope this works. Let's see. So here you can clearly see the sample test cases are getting passed. So let me hit the submit button quickly. So you can clearly see here all the test cases are getting passed, means the code works absolutely correct in this case, right? I hope the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.